Slides are very difficult for network engineers to do. Good morning again, everyone. Salamat pagi. My name is Sheryl Hermoso. I'm a network operations engineer for APNIC, and I'm here to talk a little bit about the IPv6 deployment experience that we have at APNIC. Before doing that, I'd like to share some statistics, some graphs with you that I'm hoping you would find interesting. Let me start by showing this graph of the IPv6 deployment, graph adoption rate for Southeast Asia. So within our region, we have actually managed to increase the deployment rate from about 1.5% in 2014 to 2017. We now have about close to 5%. Which is really good. That's 300% increase from the last 3 years. However, this week, we managed to reach, I think, 20% deployment rate in the worldwide IPv6 adoption. So considering that number, our growth in the Southeast Asian, the ASEAN region, is actually very well behind. Looking at the different economies in our region, Malaysia has been up there with close to 20%, which we know they have been one of the leaders in this field for quite some time now. However, Vietnam is coming in second, close to 10%. And this is a really good story. I was in Vietnam last year to witness and see like how some of their biggest network operators have deployed IPv6. So it's only within 2016, and they're targeting up to 2019 to fully support IPv6 technology as their main IP transport. Next to that, we have Thailand, we have Singapore, but the rest of us, including Philippines, where I came from, and also Indonesia over there, is actually lacking way behind. Now, focusing a little bit on Indonesia, what have we got there? It's actually, there are some spikes here and there. People are trying, people are introducing IPv6 here and there, but overall, it's actually very low percentage at less than 0.5%. These are the major players that we have. It looks good with some of them, with 50 to 60% IPv6 capabilities and IPv6 preference. However, we have to also look at the number of samples, which, as you can see in this slide, is very, very minimal. So what it's telling us is I'm pretty sure that most of the operators that we have in this room are trying their best to maybe start testing and deploying IPv6, but so far we have not seen any significant or major changes within the country, within Indonesia. So hopefully this does not discourage anyone from doing it. I'm actually hoping that this is a start for us to actually look more intently into making this possible for everyone. So what is the problem? What's holding us back from doing IPv6? Where are the issues? And just this year, 2017, in June, came up with this state of IPv6 deployment that they published, and they're looking at the different industry sectors and observations with their IPv6 deployment. The backbone, transit, as well as broadband ISPs has been for a very long time seen as the major hurdle or bottleneck in IPv6 deployment. However, in the last 3 years, we have noticed that this is not the case anymore. Broadband ISPs, major telcos have now been advertising IPv6 in BGP. So where is the bottleneck then? What about content, network providers, data centers? We know that some of the largest content providers, Akamai, Facebook, Microsoft, of course, Google, and a few others, they have actively been involved. They are active in the community, sharing their experiences on their IPv6 in IPv6 deployment. So I guess majority of their networks are already on V6. Just look at LinkedIn. They have published some series of blog posts. Maybe like me, most of us in this room have followed that through. They shared their experiences of deploying IPv6 on their data centers in 2016, and they're hoping to completely turn off IPv4 in around 2018. A lot of the major players, broadband ISPs in the US, Comcast, Sky in the UK, Telenet in Belgium, have all reached more than 50% of IPv6 deployment. Now, what about IoTs? Internet of Things has been seen to ramp up the IPv6, presence in the consumer market. We know that some of the IoT devices are still running V4 or other wireless technologies, but some of the major players that are coming up and about are now looking at technologies such as 6LoWPAN. So basically, it's IPv6. With mobile providers, wireless and cellular networks, I noticed that they are the major players in the IPv6 deployment. Majority of these wireless cellular providers are now all on IPv6 and are planning to turn off IPv4 very, very soon. Which brings us to the last sector, which is enterprise networks. This, I think, is the elephant in the room, okay? If the backbone, if the upstreams, if the transits are all ready for IPv6, how come the enterprise networks are not following through? I believe that is the next step that we have to focus on to encourage everyone, okay, end users, the last mile of the, basically the IPv6 chain, should now be looking at seriously implementing IPv6. Which brings me to my talk, and I want to share with you our experience at APNIC in deploying IPv6. Enterprise network operators, such as ours, I suppose, will need to transition into a technology such as dual stack to ensure that all our internet-facing services, may it be website or any other services that we're providing, are accessible over both IPv4 and IPv6, while also introducing IPv6 access within our local network, within our IT infrastructure, Wi-Fi, Ethernet, LAN, WAN, pretty much for our enterprise users. The APNIC network is a good example of a small to medium-sized network. It's not big. It's not like Facebook, who has like billions of users worldwide. It's a corporate network. Our office is in Brisbane. We have about 80 people in the company. But we also do provide critical service, particularly DNS, reverse DNS, and the WHOIS database. And now we're also deploying RDOP and RPKI, which are used by a large portion of the internet community. So what are the motivations for our IPv6 deployment? Well, I can see there are three. The first one being promoting and supporting IPv6 deployment in the region. APNIC, as you know, as the regional internet registry for the Asia-Pacific region, has been strongly promoting IPv6 to everyone in the community, from ISPs to network operators to enterprise users to academics. We have done a lot of workshops. We have done a lot of community engagements to encourage people and to support people to deploy IPv6. So, which leads us to the point that, well, we should, of course, walk the talk. So, I think it's just suffice to say that we have to also deploy IPv6 on our networks, aside from the obvious facts and obvious advantages that we can see by doing so. So promoting and supporting IPv6 deployment is something that we have done and we've continuously doing over the past 10 or maybe even 15 years. We can even have a slogan, APNIC, promoting IPv6 since 2001 or something like that. The next two reasons are related to the infrastructure that we support. So providing critical DNS infrastructure and also providing public who-is service for all of the APNIC blocks. This is the global IPv6 allocation. As we all know, we have a /3 IPv6 block. /12 has been delegated for the use for each of the region. So APNIC has received its /12 prefix. From that, we implemented our IPv6 network in the early 2000s. So probably one of the early adopters when it comes to enterprise networks. We used to have a /35 IPv6 block. So we have that initial allocation, 2001 DC0 2000/35. So this is before 2003. So if you're all familiar with the current allocation, which is a /32, before 2003 is actually generally /35s. That's why we have there, we have a /35 block. So our strategy is simple. We are still quite in the early stages of IPv6 deployment, and what we want is to deploy IPv6 in parallel with the existing IPv4 network. So essentially, that is dual stack. There was no exit strategy yet to plan and move out of IPv4. The plan is to just implement both IPv4 and IPv6 at the same time. Around this time as well, in 2003, we opted to use IPv4 tunnels for peering. Why? What is the reason for this? There was no native IPv6 upstreams available yet. This is a simplified example or diagram of our network. We have two locations, one in the APNIC office in Brisbane and another one at a data center. So we have two upstreams. One is using IPv4 only, and then we had to connect to Hurricane Electric. So most of you might be familiar with HE. They're providing IPv6 tunnels through IPv4, and that's exactly what we did. So going back here. So when it comes to our IP addressing, it's also pretty simple and pretty straightforward. We have a /35 block. We can subdivide it into smaller /48s. So we split our /35 into /48s and then into /64 blocks, and then created one VLAN. Out of all the VLANs that we're supporting, we had VLAN 10 as the only one that is doing IPv6 to begin with. So that's VLAN 10, 2001 DC0, 2000:10/64. So you will notice that, like for most enterprise networks, the naming conventions that they try to follow are similar to either their IPv4 addressing or trying to replicate some of the numbers that they use, such as port numbers, or in this case, VLANs. So we have a number of VLANs and VLAN 10. It's easy for us to see the /64 block here because it's part of the IPv6 address. We then had to configure IPv6 to our upstream. In this case, as I've said, we're still only going through Hurricane Electric, and so we advertise our /35 block going through them. We have configured the VLAN to use a VLAN 10 interface, having a /64 network. And then from there, we configured our Cisco router interfaces, again still using VLAN 10, connected workstations into these VLAN for testing. And so the reason for this is to one by one put networks, put services and workstations into this particular VLAN, and then verify first the IPv6 auto configuration if it's working properly, and also verify reachability before moving into doing the same thing and replicating this into all other parts of our network. One of the goals that we have in doing this is also to make all of our services, particularly DNS and the web, available via IPv6. So the first part is implementing IPv6 on our DNS. So we were running bind on a Linux machine. As you can see, as I go through, we do use a lot of open source software on our network. So bind, of course, is one of them. And we're running bind since the very early stages. So we enabled bind to listen to IPv6 address and then created, well, the interface that we're using here uses 53 as the IPv6 address. So it's very straightforward, really. So that's our addressing plan. We have /35s, then /48s, and then /64, and then expanded all throughout our IP network. By the time that we have all this infrastructure ready, we are now ready to deploy IPv6 for our DNS infrastructure in the production networks. So at this point, we now have a /32 block. So we have moved into, past 2003, we're now distributing, of course, /32s instead of /35s. We have 3 locations, 3 sites, Japan, Australia, and Hong Kong. So in Japan and in Hong Kong, we have assigned /35 blocks. And both of these sites are serving as our secondary DNS locations for our secondary DNS servers. Australia also has a /35, but aside from hosting our secondary DNS, we also host other APNIC services such as web, mail. All of our mailing lists and FTP are all located and based in the APNIC office in Australia. So I'll just go through these different services that we are doing. Particularly DNS, web, FTP, mail, and how we got through deploying IPv6 throughout them. The first one that we want to be available on v6 is, of course, DNS. Why? This is a precursor to the rest of the network. We have DNS server for the domain apnic.net had to be configured first before we can make our APNIC website available out there. So the setup is easy. Basically, assign a static IP address on the apnic.net website or server, configure it to listen to IPv6, UDP, and TCP on port 53, and then adding the same ACLs for both IPv4 and IPv6 traffic. This last part is essential because most of us do tend to forget doing this. If we are not sure, it's always good to begin with copying or creating a similar set of access lists and policies as we have in IPv4. And then from there, we now can add quad A records for our DNS. As you can see there, we have NS1, TINI, and NS3.apnic.net. Both are now accessible and can be, you can do your you can resolve from these DNS servers via v4 and v6. Now, one thing that we had to do there is to minimize the time to live, the TTL values, to 5 minutes. This is essential if you're just starting out so that you can easily roll back. If something goes wrong, okay, you don't have to wait for that very long propagation time. Most of the domains that we do host and we do provide actually have very large TTLs because they tend not to change much over time. But when initially doing this, we had to set the TTL values to a small value just so we can do a rollback very quickly. From there, we can now update the apnic.net glue records from the domain registry to now also include IPv6 addresses. So that's how we started with DNS. The very first one is the apnic.net domain, followed by all the other domains, forward and reverse domains that we do support. Next is the web. So this is the second, I guess, service that we made available. As for websites, this is the first website that has been IPv6 enabled since the early 2000s. So www.apnic.net has an IPv6 static address. we used Apache and configured Apache to listen on IPv6 TCP port 18443. As you all know, if you're using Apache in your network, I think from Apache 2.0, it already has support for IPv6, and that was in the early 2002. So not so much issues doing this for us because the software has support for IPv6 from early on. So what needed to be done next is just to add the quad A records in DNS for the domain www.apnic.net. That's it. The next one is FTP. FTP is, I guess, one of the earliest services that we have provided for the community. Up until now, it hosts a lot of the documents, the reports that we have used either in the APNIC or the Whois database are also in the FTP. So it's essentially just updating the ftp.apnic.net host with IPv6 static IP address, making available the FTP service to listen on the TCP port 21, and adding quad A records. Pretty straightforward there. Mail is one of those services that we tend to, we cover quite a lot because we host multiple mailing lists for the community. So it's essential that it is up. It's essential that we also make them available on V6. So we have a mail gateway, which is previously running the Barracuda spam firewall. However, it wasn't until 2008, I believe, that they started providing support for IPv6. So we moved to using Halon. Halon supports IPv6 for all incoming and outgoing IPv6 SMTP sessions. We use IPv6 by default for all of these services, and then if anything is not supported, like on reachability, it fails over to IPv4 if the connection fails. One thing with this that doesn't have V6 support is just the anti-spam, antivirus definition updates are all done via IPv4. With MailStore, we use Courier IMAP. Again, this is one of those services that have had support for IPv6 from early on. I think it was around 2003 when they started supporting IPv6 from version 2.6 or 2.8. However, we then had already moved to Microsoft Exchange, which of course still works very well and seamlessly with IPv6. Same as our mail gateway, we use IPv6 by default and then fails over to IPv4 when connection fails. We also have a load balancer. So some of our services goes through an LTM, and we use F5 Load Traffic Manager, which has full support for IPv6 for load balancing. We use this quite extensively, particularly the feature that allows IPv6 virtual servers. So even though the backend is only IPv4, okay, we have a service pool, only IPv4 going to the LTM. Beyond that, it can have or it can provide both IPv4 and IPv6 service. You might notice, or maybe you won't, but we use load balancing quite a lot for the Whois service. And this feature for IPv6 virtual server has been used quite extensively for the Whois services. How about for the APNIC internal network? For as long as I have been part of APNIC, we have already been using dual stack network for LAN, for Wi-Fi, and during the World IPv6 Day for this year, I think we have started using IPv6 only for our Wi-Fi. Everything else, Wi-Fi authentication, radius, LDAP, are going through IPv4 by default. We have VPN, so whenever we're all out of the office, we do access VPN using SSL VPNs, and it assigns both IPv4 and IPv6 address. Authentication going through our Active Directory services are also over IPv6. Now for our members and the members of the internet community, we provide IPv6 Anycast. So initially, it's just for e.inadra.arpa, which is running dual stack Anycast DNS server with that IP address .101 for both v4 and v6. We have Brisbane, Hong Kong, and Tokyo. So these are, this is the diagram that shows our IPv6 Anycast service. We have also started doing Anycast For most of our other DNS services, such as the support for CCTLDs, for developing countries, the APNIC domains and name servers are also all started running on IPv6 only, IPv6 Anycast. So we have presence in Australia, Singapore, and Japan. For whois.apnic.net, we have started looking for hosting them on the cloud. So far, we have site locations in Brisbane, Tokyo, London, and Fremont in the US. All of these have dual stack access support. It has load balancing as well for all whois servers beyond that are all using IPv4 internally. So this is how it looks like, IPv6 service in the cloud. Our whois services, the 4 sites there are all in the green boxes. And then the infrastructure behind the whois, the MySQL, FTP are all on the orange or pink boxes at the bottom. So lessons learned, it will be different from you, like how you're deploying things, but essentially we want to be able to test, okay, for all our services before fully implementing them and making them a service available for everyone. For DNS particularly, you would want to set low TTLs initially for easy rollback, and you must have working reverse DNS for IPv6. That is true and that is important as well for mail. If you notice the second line, IPv6 reverse DNS must be working, otherwise your mail might bounce. If you're using SPF for IPv4, it's also always good to have an existing one similar to your IPv4 setup, and make sure to update all your firewalls and ACLs. Now, for most of our internal network, we are running IPv6 by default, so it's not easy for us to notice any problems or any issues when the problem is happening on IPv4, because by default, when we test, it's via v6. So when you have your monitoring systems, make sure that you review your monitoring. The behaviors might change when v4 and v6, and make sure that there is duplicate checks for both v4 and v6. Monitoring hosts must be running on dual stack. It should have support for customized scripting to suit all of the requirements as well. And monitor services coming from external networks, because some of them is via v4, some of them are via v6. IPv6 services in the cloud, most of us are starting to diversify our networks and moving everything to the cloud. Check the cloud providers. Amazon AWS now have support for IPv6. Linode, we've used them quite extensively as well. They have support for IPv6 in most of their locations. However, a downside is they don't have any DNS-based geolocation traffic management. We have also used DNS quite extensively, particularly with our DNS services. We have geolocation, they have traffic management, it works pretty well. However, for us, for a not-for-profit organization, it's quite expensive and their pricings are not transparent. So just some of the downsides, and it's up to you to find out how these services, maybe they're in the cloud, maybe your local services that you are deploying, how they're going to support your network or your services moving forwards as you move and transition into IPv6. So those are just some of the lessons that we have learned as an enterprise network. We hope that it's something that you find interesting as well, and we can talk about it after this if you have any questions that are specific to DNS or whois or RPKI and things like that. So with that, I think that's the end of my presentation. Thank you very much for listening. You have any questions? Yes, sir.
Check. Okay. Good morning, everyone. My name is Agung from BRI, one of state-owned banks here in Indonesia. And also, thank you, Ms. Sheryl, for sharing about IPv6 to us all. As mentioned before, enterprise networks, especially the local ones, are the biggest challenge today on implementing IPv6. In my case, it was a fear out of extensive efforts which needs to be done. So I'd like to hear your suggestion on how to influence a CDO to implement IPv6 on their corporate networks. Thank you.
Well, that is a very hard question. How do you influence CTOs, CEOs, management, then decision makers to implement IPv6? Are there any CEOs or CTOs in the room? I'm not a CTO myself, so I'm not exactly sure. However, what we have been doing at APNIC, as you know, we try to reach out to everyone. We have, for the past 10 years, been doing a lot of workshops that is targeted towards the technical community, which is you and me, network operators, network engineers. We have, though, in the past maybe 2-3 years, starting moving into reaching out more into decision makers. So there are platforms, there are events where we would go to that targets most of these high-level officials, I would say, and allow them to see the benefits of deploying IPv6. There's really no going back. If you want to move forward, if you want to expand your network, that is the way to go. And you see this happening not just for, well, small enterprise networks might be hard to convince people, but if you show them examples of some of the larger ones, say LinkedIn has done a really extensive job at doing this and telling the community about their experiences. Microsoft, even though they got, say, a very big chunk of IPv4 last, maybe 5 years ago, they have also started implementing and moving towards IPv6. So I guess it's a collective effort from everyone. So if you show them examples of what is being done in the community, that might help a little bit. I don't know, and anyone else might have other suggestions too, and we're welcome for that. Yes, sir.
Just one comment from me. My name is Wita Laksono. I'm APNIC host master, internet resource analyst. So I allocate IP address to all of you guys here via IPG or IDNOG. So allow me to speak in Bahasa in relation to that question and also my campaign of IPv6. So sebenarnya kita sudah mengkampanyekan IPv6 ini sejak beberapa tahun yang lalu ya Bapak Ibu sekalian ya. Kita sudah lakukan banyak training, kemudian mempermudah mendapatkan IPv6. Jadi kalau Bapak Ibu sekalian membernya APG atau IDNIC yang sudah punya IPv4, akan dapatkan IPv6 dengan free of charge, gratis. Ya, jadi itu yang saya tahu, nggak tahu kalau peraturannya berubah, tapi itu yang saya. Jadi untuk member APNIC, as long as they have IPv4, they can get IPv6 immediately without any evaluation process. We have what we call one-click IPv6 to get the resource into your organization. So basically, we want to make things easy for everyone, and also because the IPv4 just almost finished, totally finished from our resource pool, then you guys should really start to using IPv6. Not probably in the in the production, but at least just announce the IPv6 block that you have. So advertise aja ke internet, walaupun itu belum dipergunakan sampai ke level user. Jadi kalau baru di configure di core network atau di distribution routers, things like that, just try to advertise it. Don't worry about that, and then create route object. Just to show that this is your IP address, IPv6 address block, and the S number who announced it. So at least, everyone in the internet will recognize it. So, jawaban tadi dari Bapak yang sebelumnya, bisa diyakinkan ke CTO atau CEO atau decision maker, once IPv4 finish, means that, you have, either use NAT, which is not really, well, I don't know, not really good probably. So the other best solution is to start using V6. Karena sekarang ini sudah mulai banyak orang menggunakan IPv6. Shane already mentioned about some big companies and other, not just big companies, there are many other companies that using IPv6. And don't forget to run also the quad record, A record in your DNS. If you can do the dual stack configuration, that'll be awesome. That'll be great. So again, please, ini tanggung jawab salah satu tugas saya untuk Indonesia. Jadi silahkan pergunakan IPv6 Anda. Kalau belum dapat, silahkan request ke hostmaster IDNIC atau FG. It should be very easy. Kemudian kalau ada kendala, boleh silahkan discuss in IDNOG mailing list. Kita bisa berbagi success story of IPv6 deployment, in the mailing list. So whoever haven't joined with the mailing list, so this is your time to join. And yes, siapapun yang punya experience, good story about how they implement IPv6, just throw it to the mailing list so people can get the benefit from the communication. Ya, I think itu saja. Kemudian kalau ada pertanyaan spesifik bagaimana best practice yang bisa kita lakukan untuk mulai menggunakan IPv6 ini khususnya untuk di Indonesia, silahkan email ke saya. Email saya paling gampang, wita@apnic.net. Silahkan kirimkan pertanyaan apapun. Jadi target kita kalau bisa by the end of this year or next year, IPv6 deployment rate di Indonesia itu sudah meningkat 2 kali lipat kalau bisa. Ya Pak ya, optimis. Kita harus optimis bisa. Oke, terima kasih. Thank you.
Terima kasih Bapak. Thank you. Terima kasih Bapak, informasinya nanti juga mungkin bisa